Alright, the point 2, 3 is on the graph of y is equal to f of x. Determine the corresponding coordinates of this point on the graph of y is equal to negative 2 f of 2x plus 5 minus 4. Okay, so what we want to do here is we want to assess all of the transformations that occur to f of x to get us to this transform function of y. And then what we want to do here is, so after we do the assessment of transformations, and we should do this in words, then what we want to do is create a transform equation. So this process here is called mapping notation. So what I'm going to do here first is I'm going to write down all the transformations. Now we want to think about the transform function y is equal to a f of b x minus d plus c. Okay. Now we need to consider the a, the b values, instead of using b I can use k, but it doesn't really matter what the template, whatever variables you use, right? So different schools will teach different variables, right? A is your vertical modification factor, 1 over k is your horizontal modification factor, right? And d is your horizontal shift, and c is your vertical shift. Okay, so a here is equal to negative 2. K here is equal to 2, so 1 over k here is equal to 1/2. D here is equal to negative 5, and C here is equal to negative 4. So having said that, the first transformation I'm going to look at, and you always want to do your vertical and horizontal modifications, which includes reflections first, and then you want to do your shifts. All right, so the first transformation here is a vertical reflection. Okay, so vertical reflection or reflection over the x-axis. Okay, so it's a reflection over the x-axis. And in the second case, so after we looked at the negative, right? Oh, and this vertical reflection should look like, and if you're looking at this as a function standpoint, it's negative f of x. In the second case, we have this 2 value here, and this implies, because the a value is greater than 1, this implies we have a vertical stretch, right, by a factor of 2, right? So we have a vertical stretch by a factor of 2, and this is equal to negative 2 f of x. Okay, so that's just in function notation. So we're slowly building, we're slowly piecing together this transform function from our general function. Now the third transformation, okay, so in our third transformation, this should be a 3. In our third transformation, we have this k value, and we know that the k value is 1 over k, so this implies that we have a horizontal compression by a factor of 1/2. So we have a horizontal compression by a factor of 1/2, right? And what this looks like in function notation is negative 2 f of 2x, right? So in function notation, we're just kind of building the function together, but in that case, the transformation is still a compression of 1/2, right? So it might look different in function notation in comparison to the actual transformation. In the fourth scenario, we have this d value, and we have a horizontal shift 5 units left. Okay, so this horizontal shift 5 units left, this implies that the reason we have a horizontal shift 5 units left, I think most of the times you guys would have learned this as they take the opposite sign on the inside of the bracket. This is mainly because of the fact that the format is actually x minus d. So if d is equal to negative 5, then x minus d is x minus negative 5, which is x plus 5. So that's why the sign actually looks inverted. So that's the horizontal shift 5 units left. And the last transformation we have is the vertical shift 4 units down, right? And what this looks like, oh, forgot to write the previous transformation, but the horizontal shift 5 units left is 2 f of 2x plus 5. Okay, in this case we're doing horizontal shift 4 units down, which is negative 2 f of 2x plus 5 minus 4. Okay, So those are all of our transformations. Now what we want to do is we want to create a transforming equation. So a transforming equation, which is this really the process of mapping notation. A transforming equation is basically what kind of transformations do we apply to x and y of the original function to get to our transform function. So what I'm going to look at first is the horizontal transformations. So I have a horizontal compression by a factor of 1/2. So I multiplied my x values by a half. There's a horizontal shift 5 units left, so I subtracted 5 to the x values. There's a vertical, so now after I've looked at my horizontal, then I look at my vertical transformations. So on the vertical axis, or on the y values, I had vertical reflection, so that's negative y. Vertical stretch by a factor of 2, so negative 2y. And a vertical shift 4 units down, so negative 2y minus 4. Okay, so this guy here is our transforming equation. What you want to do with your transforming equation is you want to take an original point on the parent function and you want to plug it in to find a point on its equivalent point on the transform function. So the way you're going to do this, I'm going to substitute the original point 2 and 3 into this transform function. So for the transformed x value, the new x value, you have 1/2 times 2 minus 5 and negative 2 times 3 minus 4, right? In this case, we basically got 1/2 times 2 is 1 minus 5, so this is negative 4, and negative 6 minus 4 is negative 10. Okay, so this is your equivalent point on your transform function.